So which air is heavier than which one? So dry air or the moist air? Normally we understand that maybe it is the moist humid air would be high, like heavier than the dry air, but it's not. Okay, just does a volume of hot humid air with more than a similar size volume of hot dry air? So the answer is always no. Why is no? So let's examine that. At the same temperature and at the same level, humid air with less than the dry air. So we are referring here the gas, not the droplet, liquid droplet. So to understand why, we must first see what determine the weight of atom and molecule. Almost all of the weight of the atom is concentrated in its nucleus, and where the proton and the neutron are found. So neutron weighs nearly the same as proton. To get some idea of how heavy an atom is, we simply add up the number of proton and the number of neutron in the nucleus. Electrons are so light that we don't count as a weight of electrons. So the atom weight is neutron plus the proton number. The larger this total, the heavier the atom. Now, we can compare one atom weight with another. For example, hydrogen, the lightest known of all atoms, has only one proton and its center there is no neutron. Well, it has atomic weight 1. Nitrogen with 7 proton and 7 neutron. It has a nucleus and has an atomic weight 7 plus 7 is equal to 14. Oxygen with 8 proton and 8 neutron, and this 8 plus 8 is equal to 16. So oxygen atom weight 16, nitrogen atom weight 14. So we are talking to why the air is heavier. Which one is heavier? Well, let's see. A molecule weight in the sum of the atomic weight of its atom. For example, molecular oxygen with 2 oxygen atom has a molecular weight of 32. The most abundant atmospheric gas, molecular nitrogen, has molecular weight of 28. When we determine the weight of the air, we are dealing with the weight of the mixture actually. As you might expect, a mixture weight is a little more complex. We cannot just add the weight of all its atoms and molecules because the mixture might contain more of one kind than another. However, the air, for example, has far more nitrogen. It's approximately 78% than the oxygen, which is 21%. We allow for this by multiplying the molecular weight by its share in the mixture. Since dry air is essentially composed of nitrogen and oxygen, which is combined 99% of the total gas, we ignore the other parts of the air for the rough average shown in this table over here, table 2. Well, water vapor is composed of 2 atoms of hydrogen and 1 atom of oxygen. It is an invisible gas, just as oxygen and nitrogen are invisible. It has a molecular weight. It, it's 2 atoms of hydrogen. Each atom will weight 1, and 1 atom of oxygen. Atomic weight is 16. So it gives the water vapor a molecular weight of 18. 16 plus 1 plus 1 is equal to 18. Obviously, air at nearly 29 weight appreciably more than the water vapor. So the air is consists with oxygen and nitrogen. that molecular weight is 29, and water vapor, the molecular weight is 18. So air would be higher weight than the water vapor. So suppose we take a given volume of completely dry air and we can weight it. Then take exactly the same amount of water vapor at the same temperature and weight it. We will find that the dry air weighs slightly more. If we replace dry air molecule one for one with water vapor molecule, the total number of molecules remain the same, but the total weight of the drier air decreases. Since density is mass per unit volume, hot, humid air at the surface is less dense than the hot, dry air. So let's talk about some facts. This fact can have the important influence on our weather. The lighter air became, the more likely to rise it above. All other factors are considering that's being equal. So hot, humid air will rise more readily than hot, dry air. It is of course the water vapor in the rising air that changes into liquid cloud droplet and ice crystal, which in turn grow larger enough to fall earth as a precipitation. We understand that. So on a lesser important weather, but the greater importance of to the sports, that if we kick a ball, football or something, any volleyball, football, whatever you would like to say, in the dry air, it will go little less than the moist and hot air. Well, this is complex. It's not the fact. Let's talk about the real climatic fact. So over here, when warm is heated up, warmer, less dense, and also if more evaporation happens, then this water vapor with air is going up all the way here, making cloud, and this condensation happens, then it's become cool due to releasing the heat into the space, and then it's becoming colder, and this colder, more dense with less humid air is coming back to the earth. This cycle is happening, evaporation. So we now know that the dry air is heavier than the moist air.